Welcome to the channel. The purpose of channel is to facilitate students in learning physics at their convenience. It is a class without a classroom, so learn physics at your convenience. Let us start our today's lesson, that is electric potential. Students, we define it: work done per unit charge to move it against the field is called electric potential. Look at this diagram. If there are two oppositely charged parallel plates, plate A is above the plate B, there is a separation between them. Plate A is horizontal plate, positively charged. B plate is also horizontal plate, negatively charged. Students, there is an electric field between them that is directed from positive towards negative. This is the direction of electric field represented with E. It is acting downward in this situation. Now students, if we are having a positive charge and we want to move it from point B towards point A, means we are moving that charge against the field. Whenever we move against the field, we have to apply force and the charge covers some distance, so work is done on the charge. This work done stores in the charge as its electric potential energy. So electric potential is defined as the work done per unit charge to move it against the field. So voltage or electric potential is defined as work done per unit charge. If W amount of work is done in moving a charge Q against the electric field, then the voltage is defined as V equals to W over Q. Work done per unit charge. How much work is done on a unit charge to move it against the field? Student, the unit of potential or electric potential is joule per coulomb. Joule is the unit of work or energy. Coulomb is the unit of charge and it is called volt. So 1 volt is the potential difference or electric potential at a point if 1 joule of work is required to move 1 coulomb charge against the field to bring it to that point. Students, now what is potential difference? Let again consider the same two horizontal charged parallel plates. One is positively charged, other is negatively charged. What is the potential difference between these two plates or between point A and B? Again, we want to move a charge from lower potential, means point B, to a higher potential, means point A, against the field. So the energy, that is we call the electric potential energy per unit charge at point B is UB and energy per unit charge at point A is UA. When we move the charge, we perform some work on it and this work stores in the form of electric potential energy. So change in electric potential energy of the charge is equal to the work done per unit charge. If UA is the potential energy at point A per unit charge and UB is the potential energy per unit charge at point B, then the change in potential energy of the charge is equal to work done in moving the charge from point B to point A, where I repeated UA per unit charge is the potential energy at point A and UB per unit charge is the potential energy at point B. So change in potential, higher potential energy minus lower potential energy. Change in potential energy is equals to work done. You know, potential energy per unit charge at a particular point is called voltage or potential at that point. So UA over Q is VA and UB over Q is VB. Voltage at B means potential energy per unit charge at B. Voltage at A means potential energy per unit charge at point A. This is equal to work done in moving the charge from point B to point A. This is called potential difference, or change in potential between, or potential difference between points A and B is defined as work done per unit charge to move it from point B to point A against the field. Again, the unit of potential difference is volt, joule per coulomb or volt. Potential difference between 2 points will be 1 volt if 1 joule of work is required to move a 1 coulomb charge against the field between these 2 points. Student, in this context we use another term, and that is called EMF, or electromotive force. Look at this diagram. A bulb is connected with a voltage source or a battery. To maintain the steady flow of current in the bulb, we need a constant potential difference across its terminals. Means the rate at which energy is being consumed by the bulb should equal to the rate at which the energy is being supplied by the source. So this battery or source that maintains a constant potential difference across the terminals of a resistor and bulb, in this case here, is known as source of EMF, source of electromotive force. Students, when the charge enters into battery from its negative side, the battery performs some work on it and rises this charge from lower potential to higher potential. This work done by the source in moving the charge from lower potential to higher potential is known as EMF of the source. What is source of EMF? A device that converts non-electrical energy into electrical energy is called source of EMF. So this battery is a source of EMF that is used to maintain the constant potential difference across the terminals of a bulb or resistor. So it converts chemical energy, in this case, into electrical energy. It is called source of EMF. And what is its EMF? I told you, when charge enters from negative side, this battery rises this charge to higher potential. So it performs some work on the charge. So work done per unit charge by a source to move it from lower potential to higher potential. Means the energy supplied by the source to the charge while it is moving from lower potential to higher potential. And when the charge passes through the source provides its energy. And that energy supplied per unit charge is known as EMF of the source, or it is defined as work done per unit charge. Again, it is similar to electric potential, same as to electric potential. So its unit is also joule per coulomb, called volt. This is all about the voltage or potential difference and electromotive force. I hope it is clear, students. Thank you for sparing your time to watch this video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.